So in one video, I talked about how this first equation right here can be used to explain how electromagnets and how motors work, and how this second equation can be used to explain how generators work. And so in this video, I'm going to talk about transformers, and the way transformers work is they combine both of these two ideas. Because essentially what happens is that you have a loop of wire right here. This loop of wire, I'm going to inject current into it. I'm going to make current flow. As this current flows, it's going to create a magnetic field that points up and around the loop. Here in the other video, we talked about how a loop of wire, if you take a magnet and you drop it through, or if you were to spin the magnet, when the north side of the magnet approaches toward this loop, current is going to flow in from this top and wrap around in a left-handed direction around this loop. While here, current flowing around in a right-handed direction will point a magnetic field up. So you might kind of see then how if you were to place both of these loops near each other, how you would actually get current flowing on both sides. Current is flowing here from this side and current is flowing here, and as you place these two loops together, the same thing is going to happen. But something to note, current will only flow on this side if the magnet is sort of moving, or the magnetic fields are changing. The magnetic field has to change. So if I only have a DC current, well, no current is going to happen on the other side because this magnetic field is constant. The only way we can make this is if we take this magnet that is created and constantly flip it back and forth. How might we do that? Well, instead, we're going to use alternating current. So I'm going to have like a sine wave. So the current will go positive, and then it will flip around negative, and then positive again. And when we have this alternating current, what's going to happen is that current is going to flow in from this top side, but it's actually going to be flipped. Instead, it's going to go negative, positive, and negative again. And so this is why we need alternating current all the time in electronics, because most importantly, it's really useful for transformers. Transformers cannot operate with just direct current. You need changing alternating current, because what happens is that this magnetic field will alternate and flip back and forth. Flipping back and forth, or spinning or moving magnets, will cause current to flow on this other loop. And so this is why we always have transformers throughout electronics. And this is actually the reason how wireless charging works. Because although these two parts of the circuit are not connected and current only flows around in this direction, well, current can still be induced on this other side of the loop. And so this is how wireless charging works. This side might be the charging pad, and this side is going to end up being your cell phone. So inside of your cell phone is actually a bunch of loops which act to catch magnetic fields. Now, one last thing is that transformers are really useful for stepping up and down voltage. And how do they do that? Well, what ends up happening is you have one loop with, let's say, two loops, and this other loop with, this other coil with four loops in it. And I'm going to inject the same alternating current into this wire. So we have an alternating current, current versus time, and so what's going to happen is that magnetic fields are going to point up and down through this loop, or flip around depending on whether or not we're on the negative cycle. And as these magnetic fields loop through, what's going to happen? Well, the magnetic fields are going to create electric fields that wrap all around them. So in other words, you can kind of think about more loops on this side of the transformer as being able to catch more of the electric fields. The more wire you have, the more of the electric fields you end up, quote, catching. And so the more electric fields that are experienced, the more voltage you get. So essentially, because these electric fields apply a force onto the electrons, and this force creates more energy in the electrons. So here's the electric field, and here's energy. And so more energy means more voltage. So the other side of the loop is going to get more voltage than the left side of the loop. Now, here's a thing though, because although you suddenly get more voltage on this side, energy is not created. Because here's what happens. Current will flow in this direction, in the opposite direction, and it's going to create an opposing magnetic field that tries to cancel out the original field. And so what ends up happening is that this current that I have here ends up getting slowed down. So maybe now the current is only half as strong when I put a loop near it. So energy is still conserved in the system.